method setup. This will be given by Velibor Škobić, and this is joint work with Nebojša, Pjevalica and Miloš.
Thank you. I can say the title of our temporary verification of frequency setup analyze experimental setup. What we do in this paper, in this paper highlight two things. First is automated setup for measurement of frequency of harmonics of the signals, and first is automated setup, who is controlled by application on the computer, who's using application who's have commands to control signal generator and oscilloscope for measurement. The goal is to measure the harmonics. Our future work will be to test brushless DC motor to generate some signals, some shape of signals, and to sample the response of that signal on that signal. The purpose of that is to find the position of rotor of wheel DC motor. Some application of the our first work. First thing is we create automated setup. Okay, for better results, it is desirable to exclude human factor and replace it with process automation. That is clear. I present the one application in which we use this setup. Next slide. In the automated measurement setup, some applications use communication protocols, communications or system will use Ethernet, GPB, PXA, USB, and so many communication systems. Application use occasionally some drivers to communicate with measurement of instruments or signal generator. We create own solution, own application to control different types of instruments like signal generator and oscilloscope, and different types of manufacture. Because if we use one manufacturer, we have one application solution for controlling these instruments, and we have two different instruments who using different software, different drivers, and we not have one application developed application who control that instruments. We create our application who control that instruments. Okay, our setup for that purpose is simple. We have computer switch who controls with the GPB LAN signal generator, and switch is connected with Ethernet on the oscilloscope. We have signal generator of Sony Tektronix and oscilloscope with LeCroy manufacturer. We use Ethernet switch, simple, and PC. And we develop our own, we create own application. We use VISA drivers and DSO drivers for communication with signal generator and oscilloscope. Next slide. Our application enables configuration of signal generator and oscilloscope, starting generator of signal, triggering the oscilloscope, sampling and storing the measurement results on PC. The idea is creating automated system whose with application generate some signals on signal generator. Oscilloscope will capture that signal and give back to us in application samples with second thing in the automated setup is our important thing is measurement of harmonics in the response of. We in this situation we not have a response that we generate on the signal oscilloscope. We that have it on the oscilloscope, but in the if we measure harmonic on the response of the motor, we get some response who is different than we generate signal. We generate signals of different shapes, sinus, rectangular and triangular, and we obtain two frequency analysis. First is discrete Fourier transformation we perform on the PC, on the computer, and second two is FFT algorithm who's performed on the oscilloscope with algorithms like last prime and power of 2. We compare these results and look what is better for measuring in automated system, because we don't have ability to control the oscilloscope. We only have the automated system and we control that with application, because we in the future perform to create application to generate a sequence of signals, and we capture the response and that in the real time measuring and watching how the amplitude of harmonics. And this work compare the harmonics, the amplitude of harmonics, using these two algorithms and using algorithms obtained on our PC. The discrete Fourier transformation we obtain on the PC is our referent of measurement. Okay, we generate two or three signals, different shapes, and we, if you look at table, the relative difference between a referent frequency analysis, who is DFT, is in this case of signal 1 kHz is smaller in a last prime algorithm than in algorithm of power of 2, because of number of points we calculate. In DFT algorithm, who is performed on calculated on PC, we can find the one period of signal and calculate Fourier transformation on only that period. But in the automated system, we can where we use oscilloscope, we only capture the number of periods of that signal and the number of points who we capture. It's not a number of integer number of periods of that signal, but and in that case we have a leakage of spectrum, but error in measurement. In this case, 1 kHz signal, the simple last prime algorithm, you have better results. In the next slide, we only change the frequency. We have 750 hertz, and we, if change frequency, we change the results. In this case, little better results is in the power of 2 algorithms than in slice prime algorithm. But in the automated system, we can fine control these measurements. If we use oscilloscope and FFT analyze like referent our analysis, or like exit or our measurements. This work highlights the advantage of the automated frequency measurements along with the additional benefits offered by PC-based implementation of DFT calculation by definition over single signal period, which gives exact frequency components. This automated system uses a verification system for oscilloscope, perform frequency analysis FFT. We conclude that in this automated system we have error in the measurement of the frequency response of harmonics in signal, and we in this our future work we must we must this work to future work we must consider these results for future work in automated system. Thank you.
Questions? Can you achieve any price benefit when you compare this open source solution with some existing commercial solutions?
Prices in commercial solution is bigger than
when you include all the components of your system, so the PC, the oscilloscopes, and so on.
For our solution or for
when you compare your solution and you count all expenses for PC, for switch, for oscilloscope, for the hotel repair, and you compare with commercial solution existing, which has, let's say, a smart oscilloscope.
Okay, our solution is cheaper. I think we use different vendors, and we create our own application. We can control full control of the system. The application of some vendors is expensive.
Okay.